Bismillah ar-Rahman ar-Rahim. The last thing I changed. Get rid of this information. Please. Okay, can you hear me now? Hello?
Yes, doctor.
Yeah.
You can hear me?
Yes, doctor.
Okay, okay. The first thing we're going to talk about today, the rest of chapter 11, we're going to talk about phase changes. And we're going to talk of phase changes. What do you mean by phase changes?
From solid to liquid and gas and
Or liquid to solid. What else? Or liquid
To gas.
and gas to
Liquid.
good. What do you call changing solid to liquid? What's this called?
Melting.
Melting.
And liquid to solid?
Freezing.
Freezing.
Freezing. Good. Liquid to gas?
Vaporizing.
Vaporizing.
Gas to liquid?
Condensing.
You have to memorize these names. Very good. Okay, if you have solid to gas, what's this called?
Sublimation.
sublimation.
Okay, these are the different reactions in which to represent these things. Now, the first one, liquid to solid. Is this exothermic or endothermic?
Exo.
Exo.
Exo, exactly. Exothermic. If you go from liquid to solid, this means we're going to give heat out. And this is exothermic. All right. But if you go from what's this? From solid to liquid?
Endothermic.
Endothermic. Okay. From liquid to gas, is this endothermic or exothermic?
Endothermic.
Endo.
From solid, from gas to liquid.
Exo.
Exo, you have to know this. Very good. And from solid to gas, what's this called?
Sublimation.
Is this pure therm or endo?
Endothermic.
Endo. Exactly. When you say endo means what?
Gaining
Gain
heat.
heat.
Yeah, you need to put heat. Delta H will be positive or negative?
Positive.
Positive.
Yes, yes. You have to know this. Good. Now, next, boiling point. What's the meaning of boiling point?
Liquid goes to gas.
Liquid goes to gas. This is called boiling point. What do we mean by normal boiling point? Again, liquid goes to gas, but the pressure outside must be equal to what?
1 atmosphere.
1 atmosphere. Is this clear? That's called normal boiling point. Okay. Same thing for freezing. If I say freezing, what's freezing point?
Liquid goes to solid.
Solid. Liquid goes to solid. When are we going to have normal freezing point?
At 1 atmosphere pressure.
Is this clear to everybody? Good. Because if you reduce the pressure, what will happen to the boiling point? For example, water boils at what temperature? What's the boiling point of water?
100 Celsius.
What again? Normal boiling point of water is 100 if the pressure is what? At 1 atmosphere. That's the normal boiling point. What will happen if you take water up on the mountain? What will be the boiling point of the water?
Higher.
What? The boiling point of water at mountain.
Less than 100.
هاي كل ما قل الضغط، وإذا قل الضغط نقصت درجة الحرارة lower pressure، وكل ما زاد نقص الضغط كل ما نقصت درجة الحرارة. واضح يا شباب؟ I hope so. Good. Next, heat of vaporization. What's the heat of vaporization? Write a reaction in which heat of vaporization is shown. For water, for example. What's the reaction for heat vaporization?
H2O liquid to gas.
Delta H is called vaporization. Okay. Can you write delta H fusion?
Liquid.
H2O what?
Solid.
Goes to. This is the equation to represent delta H fusion. Is this clear? Is there a relation between the vaporization and the temperature, the boiling temperature, boiling point? If the temperature is very high, let's compare two things. For example, if we have water, the normal boiling point of water is 100. And for benzene, C6H6, the boiling point is 80.1. Which one you think will have higher delta H vaporization?
Water.
H2O.
Why?
Because you need more energy to
reach 100.
vaporize.
Yes, exactly. This table, don't memorize anything in it, but look here. That's the water, 100, and that's benzene, 80.1. The heat of vaporization is 40.79 for water, and only 31.0 for benzene. Don't memorize anything in this table, just keep it in your mind. that if you increase boiling point, what will happen to the vaporization? It will increase. Good. Next, I want to define critical temperature. What's a critical temperature?
And when it can't be liquid again.
Yes. Usually, if you have gas and you put pressure here, it will change to liquid. If it's gas and change, if you put pressure on gas, it will change to liquid. Clear? Always. Except if you reach TC. When you reach TC, what will happen? Gas will never change to liquid after TC. Is this clear? That's called critical temperature. Critical temperature. Clear? Any question?
Will it go to solid or not also?
No, of course. It hardly goes to liquid. It will never go to solid, of course. Okay.
Before the critical temperature, if we raise the temperature.
I can't hear you.
Before the critical temperature, if we raise the temperature, when we apply more pressure, is it going to be liquid?
No, never. That's what I'm saying.
No,
If
before the critical temperature.
After TC, you can never change gas to liquid. Never.
No, before TC. Before TC.
Huh?
Before TC.
Before TC, of course you can.
By applying more pressure, right? The higher the temperature, the higher the pressure.
This means you still can do it, yes. What's the critical pressure, PC? PC is related to C. It's the pressure at which TC is available. This is called critical pressure. It's associated with TC. We will see it in a while, after a while. Okay, good. Now, this thing here, phase changes, very important. And we want to know what will happen if I have maybe solid and I want to go to liquid or gas or whatever. Okay. Now, if you are at a point like here, for example, at X, what's the phase of X?
Solid.
Solid. What will happen? What will happen if you increase the temperature on X? It will start to go up until you reach A. When you reach A, what's the phase of A?
Solid and liquid.
Solid also.
Solid only. A is solid. All right. Then what will happen after that? It will start changing to liquid without changing the temperature. All right. And so until you reach B, what's B?
Liquid.
Liquid. If I have a point here, which is Y, what's the phase of Y?
Solid and liquid.
Solid and liquid.
Solid and liquid. Solid and liquid. When you reach liquid at B and start increasing the temperature, it will go all the way to C. What's the phase of C?
Liquid.
Liquid only. Liquid only. Okay. What's the phase of a point? Let's say Z. What's the phase of Z?
Liquid.
Liquid.
Good. Good. When you start heating at point C, the temperature will not change, but it will start gradually changing to D. What will be the face of D?
Vapor.
gas,
Yes. And if I have a point here, let's say I have point K, what's the face of K?
Liquid and gas.
Liquid and gas, exactly. Now, if you go from D upward to any temperature here, then what will be the phase here? It will be all gas. Is this clear? Good. We want to calculate what's the heat of all this process. Whatever you need, wherever you start from until wherever you end up. For example, I'll call in this case, I'll call the point from X to A as Q1, and from A to B, I'll call it Q2, and from B to C, I'll call it Q3, and from C to D, I'll call it Q4, and from D onward, I'll call it Q5. I want to find what's the Q for each one of each one. And let's start with Q1. What's Q1 equal to? Equal to the mass times the specific heat of what?
of the substance,
The solid, not any sub, but the solid part of the substance. So I'll write it only solid. Specific heat of solid times what?
delta T,
Exactly. Okay. Same thing with Q3 equal to what? Q3 is from B to C. It's equal to mass times what?
specific heat of liquid,
Liquid times
delta T.
the T. And same with Q5 is equal to what?
Mass multiplied by specific heat for gas.
Oh, of what?
Times
Delta T.
the T. Is this easy? Now, how about Q2? Which is, there is no delta T. The delta T is equal to what?
heat of fusion,
What's delta T?
0,
Zero, because it's 0 to 0 or whatever. There's no change in temperature. How can I find QT? I have to take the mass divided by, what's this letter?
Mole.
Molar mass. Molar mass, and multiply by what?
delta H of fusion,
Exactly. Then what's Q4?
the same as 2, but delta H of vaporization,
How easy? You have to know where did you start and where you end up and to do the calculation. Now, if you go from X, this is point X, to point, I'll call this one O. If you go from X to O, is this exothermic or endothermic process?
Endothermic.
Endothermic, exactly. And so the Q must be what?
Positive.
Positive. But if you go from O, this is going from X to O. How about if I go from O to X?
إكسوثيرم.
And Q should be actually negative. Is this clear? Good. This problem. Okay. Liquid ammonia can be used as a refrigerant and heat transfer fluid. How much energy is required to heat 25 gram? What's this 25 gram?
Mass.
With ammonia.
Yes. What's ammonia?
NH3.
NH3. NH3. Good. How much energy is required to heat 25 gram of NH3 from minus 65 to minus 12? Minus 65 to minus 12. We start with NH3 what?
Liquid.
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 So if I draw the drawing, something similar to this. I want you to put the information now in this drawing. Okay, given the following, normal boiling point is minus 33.4. Where is the normal boiling point in the diagram?
The second part.
Where should I put the line? Where should I write the minus 33.4?
And the second horizontal line.
Which is this point, right?
Yes.
Exactly. That's minus 33.4. Excellent. Okay. Where are we to start with? At what point?
Minus 65.
Where is minus 65? Where should I put it?
Under it.
Where? In here or here? Where should I put it? Here or here or here?
Above the horizontal line.
It should be here, maybe. Anywhere in here. That is minus 65. And then where am I going to go to?
To the gas.
I'm going to minus 12. Where is minus 12? Somewhere here.
Last. Yes.
Minus, if I draw a line, this is minus 12. Clear? Next, how many Q's should I calculate in this question?
3.
Where is the first one? Q1. Where is the second one? Q2 and Q3 only. Right? What's Q1 equal to what?
HS for liquid multiplied by delta T.
Give me number. 25.0 times what?
4.7.
4.7, yes.
It's exactly 4.7 times what?
Delta T.
What's delta T? What's delta T?
21.4.
What did you do? Well, you subtract from what from what?
Minus 12. Minus 33.4.
Minus 33.4, because it's the final temperature, minus 65. That's how we find delta T. And this should be positive, actually. What's the answer? Low,
31.6.
and is it positive or negative?
Positive.
Positive, because always, this is the final temperature. It was heated from minus 65 to minus 33.4. So this is the final temperature, and this is T final minus T initial. Clear? And it should be positive because Q is positive. Good. What's Q2?
Mass over the molar mass.
25 over
25.0 divided by what?
23.5.
No.
$17.
Yes, 17 point what?
$303 maybe.
Maybe 0.2 approximately. I don't know. Good. Multiply by what?
Eight of
Yes.
Heat of vaporization of NH3.
Which is, give me number.
23.5
Should I keep it like this, or
times 10 to the power 3.
I will change it to joule deliberately? Why? Because everything is joule here, joule here. This is kilojoule. I want to change it to joule. Clear? Okay, what's Q3?
$2.2.
No, 25 first. 25.
25 multiplied by 2.2
Yes, multiplied by 2.2 times what?
the delta T, which is
What's delta T for this one? What's the T final? Which one is the T final?
Minus 12.
Minus 12 is the T final. Minus what?
33.4.
50.
And what's delta T in this case?
21.4.
And calculate Q for this one reaction. Is this clear? How easy?
Dr. Then we add them.
Yeah, of course. If I want, what's the total heat? Okay. How much energy required to heat? How much energy? This you calculate Q total of these three. But I need only 3 Qs here. In that one, I show you 5. Whatever the condition, you have to find it and find the answer. How easy? Okay, this
Easy.
is the third question in the quiz on Wednesday. Now, what was the first question?
Ln P over P.
Laplace-Calibran equation, in which you have, yes, ln P1 over P2, and continue. What was the second question in the? What will be the second question in the quiz?
Cubic structure.
Yes, cubic crystal. Cubic crystals. Yes, in which you find the density or find the mass or whatever. Okay, what's the third question in the quiz?
Phase diagram.
Phase change. Okay, and the fourth question in the quiz will be this equation. What's the name of this equation?
Bragg.
Bragg equation. Bragg equation. I want you to memorize it. Now, write it and memorize it. N lambda equal to 2d sine theta. And I'll show you what is everything in there. N lambda equal to 2d sine theta. Okay? N, the only thing I will define now, N is called the order. Order. And if it is first order, N equal to what?
1.
Okay. If it's second order,
2.
third order, and so on.
3.
Good. So this one is the order, and I will tell you if it's first order or second order or third order. Now, did you write the equation? Good.
Yes.
Now let me define what's everything. What's D? It's the distance between the layers. You know, if you have solid, they're above each other like this. The distance between the layers is called what? D. Okay. What is the theta?
The angle,
Angle of what?
reflection,
Angle of reflection. Good. What's lambda?
Wavelength.
Wavelength. Okay. What else? And of course, N is what?
the order,
The order. What's the equation now? Let's rewrite the equation.
N lambda equal to d sine theta.
How easy?
Easy.
Very easy. Good. Let's solve this problem. Interplanar distance between two layers is 4 angstrom. What's this 4 angstrom?
D.
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 Calculate the angle of reflection for the first order. First order means what?
N equal
N
1.
equal 1.
Equal to 1. X-ray of the wavelength of 1.54 angstrom. What's this 1.54 angstrom?
Lambda.
What? Lambda. Okay. What's the equation? One more time. Let's remember the equation.
N lambda equal to d sine theta.
Can you calculate what's theta? From the question.
Yes.
11.01.
Yes, I got the same.
What's somebody says 11 point what?
0.1.
1 degree. Who's got the same answer?
I got the same.
Yes. Now let me ask you a question. What's the distance? In what unit is the distance?
Armstrong.
Armstrong. No, angstrom, not Armstrong. Angstrom. What's angstrom equal to what?
10 to the power minus.
Well,
10 to the power minus 10 meter.
yes, exactly. Do I have to change the units to meter?
No need,
Why not?
because we will divide each other, so no need.
Divide by each other and the unit will go away, exactly. But If I give you the unit in nanometer, one in nanometer and one in angstrom, what should you do?
We have to use 1 unit,
Okay.
which is
The
meter.
relation between nanometer and angstrom.
10 to the power 10 to the power 1.
To the power minus 1.
This means it's 10, exactly. And what's the relation between angstrom and nanometer?
10 to the power minus 1.
That's the point one. Exactly. You have to know this. So this is the fourth question. One like this question is the fourth question in the quiz. So I gave you already for next Tuesday, you already have 4 questions, and the 5th I will put it extra. Okay, so we're going to have 5 questions. I gave you the 4 already. Okay, clear? Any questions?
Sir,
Yes.
will the third and fourth be in the final?
Of course, everything could be in the final. I don't know what's in the final, but everything could be in the final. Yes, all of them could be in the final. Okay, but for my quiz, again, yes, all these questions will be in the quiz, and I'm sure in the final you will find, if not all of them, most of them, let's say, 3 of them will be in the final, maybe 4. Clear?
Yes.
So yes, all of them, I think you will see them in the final. I think, yeah. Last thing we're going to talk about is phase diagram. Phase diagram. And what do you mean by phase diagram? Phase diagram is a diagram in which we have temperature and pressure are the coordinates. Okay, and we have the relation between the phases of the matter. This is what's the phase of the blue color? What's the phase of blue color?
Solid.
What's the phase of yellow color?
Liquid.
What's the phase of orange color?
Gas.
Gas. Gas, of course. Okay, if I have a point A here, what's the phase of point A?
Solid and liquid.
Between liquid and solid.
Exactly. What's the phase of point B?
Liquid and gas.
Liquid and gas.
Exactly. What's the point C?
Solid and gas.
Solid and gas.
Gas. What's the phase of this point? I'll call it K, for example. What's the phase of point K?
All the phases.
Yes, all the phases. So the point K is called what?
Trouble one.
Triple point. What's the meaning of triple point?
We have all the phases.
All the 3 phases exist: solid, liquid, and gas. Clear? Last point here, what do you call this point?
Critical one.
It's called critical point. You have to know it. Where is the critical temperature? How can you find the critical temperature?
Under it. In the x-axis.
Go like this. What's this temperature now?
Critical temperature.
Where is the critical pressure?
On the y-axis.
Parallel, yes.
Good. Is this clear? Good.
Yeah.
If I am at point X and I increase the temperature without changing the pressure, what will happen to X? increase the temperature without changing the pressure?
Goes to liquid.
Goes to liquid, exactly. Goes to liquid. Is this clear? Good. What if I have point Y? I have point Y. What's point Y? What's the face of point Y?
Gas.
Gas.
Gas. Point Y is gas. What will happen if I increase the pressure without changing the temperature?
Will goes to liquid.
How is it going to go? From here to here. Clear? If I increase the pressure without changing the temperature, it will change to liquid. Is this clear? Is this clear?
Yes.
Yes.
Good. Now, if I have, I will take this point somewhere. Deliberately. If I have a point here, okay, I'll call this one now Z. If I had point Z and I increase the pressure without changing the temperature, what will happen?
Being solid.
It will change to solid, right?
Yes.
Good. Now let me ask you a question. Which is more dense in this compound? Solid or because
Solid.
when you increase pressure, what happened to volume?
Decrease.
Decrease. If you decrease the volume, what will happen to the density? Because it's mass over volume. If you decrease the volume, what will happen to the density?
Increase.
Will increase.
Very good. This means which is more dense, the solid or the liquid?
Solid.
The solid.
It is more dense. Is this clear? Good. Let's do it for water now. Again, this is for water. Okay. What's the face of point A?
Solid.
Point B.
Liquid.
Point C.
Gas.
Point K.
All three of them.
Which is called what?
3 point.
Triple point.
Triple point.
Triple point. Yes, exactly. That's K. Triple point. Yes. What's this called?
Critical point.
Critical point. How can you find the critical temperature?
Line under it.
To the x-axis. How fine can I find this is TC? Where is PC?
To the left of it and the y-axis.
PC. Good. Now, let me ask you, what's the normal freezing point of water? What should you do?
Go to one atmosphere pressure.
Atmosphere, draw a line, and then go down. This point is the normal freezing point of water, which is what? 0. What's the normal boiling point of water?
100.
But it has to be at what pressure?
1 atmosphere.
Now, if I am at this point, first, let me ask you, if I take point B and increase the temperature without changing the pressure, what will happen to B?
Change to gas. To gas.
Change to gas. Very good. If I am at point C and I increase the pressure without changing the temperature, what will happen to it?
Liquid. Change to liquid.
Will change to liquid. Very good. If I am at point X here, this point, what will happen if I increase the pressure without changing the temperature?
Liquid.
What?
Change to liquid.
Exactly. What's the face of X now?
Solid.
If I increase the pressure without changing the temperature, what will happen?
It will become liquid.
Which is more dense, liquid or what, or solid?
Liquid.
For water only, liquid is more dense, and this is very strange. For others, always solid is more dense, but for water, it is liquid is more dense. How can you prove this? If you have a cup, where is the ice in the cup?
It's
On the top.
Why?
It is less dense.
Less dense, and that's why it's float. It will float because it's less dense. Less dense. Okay, good. Let's go back to this one very quickly. What's the normal boiling point of this compound? I need an answer.
I think there is no normal.
No normal. Why there is no normal boiling point?
Because
at
if
one
at one atmosphere.
It's down there. Good. Let's solve this question very quickly. Okay, what should I write in the blue?
solid,
Yes. What should I write in yellow?
liquid,
Orange.
Gas.
gas,
What's this point?
Triple point.
triple point,
Triple point. What's this point?
Critical.
Critical.
Critical point. How can I find the critical temperature?
Under it on the Y in the x-axis.
This is TC. What is PC?
The y-axis.
in the y-axis,
Good. Which is more dense in this compound? Solid or liquid?
Solid.
Solid is more dense, yes, because if you put this point under pressure, it will change to solid. Is this clear?
Yes.
Good.
yes,
What's the normal boiling point of this compound?
Go to one atmosphere and match it.
Atmosphere and make what? Boiling point.
Approximately 200.
Will be here. This is normal boiling point. Normal. Where is the normal freezing point? Normal freezing point. Normal freezing point is there. Any question? And this is the end of chapter 11. And
How do I know?
what?
How do I know which is more dense, the solid or liquid?
It depends on the line. If you see the line like this is the liquid and this is the solid. Which one is more dense?
I'm not sure. I don't know how to know.
You have to go up because the same temperature increase the pressure. What will happen?
So that means the solid is more dense?
Yes. But if the line is like this,
Oh, okay.
if the line is this is the liquid and this is the solid. Which one is more dense?
The liquid.
And that's what happened in the water. See, if you look at water, the line is like this. It's built tilt this way, while the others, it's always tilt this way.
Yeah,
Here.
I see.
Which one is more dense, solid or liquid?
Liquid.
No?
No, here is solid. Here is solid, but water is liquid.
Yes. Okay. All right. With this, we finish this lecture, and let's go to attendance. Now attendance is open. Take attendance, and you can leave right away. And I'm also leaving.